Hi guys, this is the physics AMS for Thursday. Question 1. Which of forces will produce a turning effect? So as we know, the momentum is equal F times perpendicular distance. So for F1, the perpendicular distance of F1 is equal to 0 from point A. So the momentum of F1 on A is equal to F1 times 0 equal to 0. So this will not produce a turning effect. Momentum for F2 on A, F2 is here. So we extend the F2 and do a perpendicular from FA. This is perpendicular distance. So it's equal to F2 times perpendicular distance. Perpendicular distance is not equal to 0 in F2. So here's our value. It will cause the turning effect. F3. So we extend F3 and do a perpendicular line to FA. Also, the perpendicular D have value. So this will also cause turning effect. For F4. We extend F4, it will on the same line as A. So the perpendicular distance is equal 0. So F4 times 0 is equal 0. So F4 will not cause turning effect. F5. F5 is here. We also extend and do perpendicular line from FA. So this is perpendicular distance, also have value. So F5 will produce our turning effect. Question 2. So just the equation of momentum. Question 3. The motion in which an object has a constant speed in one direction. So just URM, uniform rectilinear motion. Question 4. We need to find the force created a moment of negative 40. So first we look at point P. Point P is moving at counterclockwise. It's nearby the A, so counterclockwise. Counterclockwise is positive, so not P. Q. Q is in the same line of the A, so the moment of Q is equal to 0. R. R is moving at also counterclockwise because it's also near to A, positive. For S, S is moving in clockwise, like this, so it's positive. And T also move in clockwise, so it's also positive. So positive is T and S. Question 5. First we know Fe equal 8 and F2 equal 10, F3 equal to 4. We need to find the net moment. So the net moment is equal m F1 on A plus m F2 on A plus m F3 on A. So first we find F1, F2, F3 is clockwise or counterclockwise from point A. So F1 is moving counterclockwise, so it's positive. F2 is in the same line of the point A, so it's equal to 0. F3. F3 is moving in clockwise, so it's negative. So we change here to negative. Then F1 on A is equal F1 times perpendicular distance. So equal to 10, so equal to 8 times the perpendicular distance is equal to 12 over 2 equal to 6, so times 2, then plus 0 minus mf3. mf3 is equal f3 times the perpendicular distance of f3 from point A. f3 equal 4. The perpendicular distance is equal to 5. The answer is equal to 28. Question 6. So F1, when we use F1 to lift this line up, the line will go from here to here. So F1 is moving in the clockwise, negative. Then we use right-hand rule. The force moving in the clockwise, we can get it into the plane. For F2, when we use F2 to lift this line up, the line will go from here to here. So it's counterclockwise. Counterclockwise is positive. Then also use right-hand rules to go from the counterclockwise. We can get it out of from the plane. Question 7. So when the box is pushing, it have the normal force, the weight, and the fraction. Because the box is moving in this way, so the fraction is to the right. We need to find which force acting on the box will produce a clockwise movement. So the moment of fraction is equal to 0 because it's on the same line of this object. And the weight is moving from here to here, is clockwise. So clockwise is the weight, and the normal force is moving from here to here, like so. It's moving in counterclockwise. So the weight moving in clockwise. Moving clockwise means it's negative. Question 8. So F1 is equal to 5, F2 is equal to 20, F3 is equal to 6. We need to find the moment of F1 on A. Because the F1 is on the same line of point A, so it's equal to 0. Then F2 on A. The perpendicular distance of F2 from point A is equal to 6. So 6 times 20 is equal to 120. But the F2 is moving in the clockwise, so it's negative. Then F3 on A. The F3 is equal to 6. And the perpendicular distance from point A is equal to 12. So the answer is 72. And also F3 is moving in the clockwise. The counterclockwise, so it's positive. Then we need to find the net momentum. So net momentum, we just F1 plus F2 plus F3, 0 plus negative 120 plus 72. So the answer is negative 48. Question 9. The motion in which velocity of an object is increased by equal amounts. So it means A is constant, UARM. So it's referred to as uniformly accelerating. Question 10. So the P is bigger than 0, smaller than F. The P is object distance. Then in this condition, first we know the image is virtual and is also magnified. And the image is upward behind the object. So the lens is being used as a magnifying glass. It's correct because it can magnify the object. Second one, the image form is virtual and upright. Correct. The image can only be seen by air cube. Correct, because the image that form is virtual. So we just can see before the lens, can't see behind the lens. Question 11. The magnitude of moment of F about the A. So F on A is equal to F times perpendicular distance. The F is 20. The perpendicular distance is 60 centimeter. 60 centimeter is equal to 0.6 meter. So it's equal to 20 times 0.6 equal 12. Question 12. The quantitative measure of the turning effect of force. So this is the moment of the force. We can also say the torque. Question 13. The magnitude of moment of the force acting on a body. So the M is equal to F times perpendicular distance. The F is equal to 20. The perpendicular distance is 0.2. Then we can get answer 4. The body is rotating in this way. So it's counterclockwise. It's positive. Question 14. Which of following are possible outcomes of a zero net force acting on an object? So when a zero net force is acting on an object, the object will remain at rest or moving in the straight line and also constant speed. So these 3 are correct. Question 15. Where should we place an object to produce a real image? So when P is bigger than 2F, we can get a real image. P equal to F, also the real image. P bigger than F, smaller than 2F, real image. But when P equal to 5, there's no image. When P smaller than F, the image will be the virtual. So when the object is beyond F, we can see the real image. where should we place an object to produce a virtual image? So here is the virtual image when p is equal to f or smaller than f. So it's between f and the optical center in here. Okay, that's all for the physics AMS. Thanks for listening.